Okay, next video is forces in three-dimensional space and looking at the vectors and how to find it. Very similar to the two-dimensional stuff we've been doing, but it is gets the K factor in. Okay, so let's start with this. I need an axis system here. And that is Z, there's X, and Y. Alright, I think I'll do this in red. So if we do a vector, no, red, thank you. We do a vector here, and we call it f of x, and we get a y component, okay, and then we have a z component, okay. We will have a vector, and I think I'm going to do this one in green just to try to make some sense out of this for you, is coming up and out and going in this direction. Okay, and I guess for the sanity, I should take that one out and make it shorter. Whoops, let's do red. And that's f of y. Alright, so, and to keep some sanity in the directions here, we have a theta z, and then we got a theta x, and then what's left is theta y. Okay, and if I was to plot this, let's see if I can do this where it makes some sense for you. We do this, and we do this, and then we do this, and you think about this as a plane, alright, and then this as a plane, okay, and then the last one, which is, did that one, oh, is this, that, okay, we're working out here in this quadrant of space, okay, alright, let's go back to, so basically we take a look at this. F of x is equal to f, which by the way is that green vector. F of x is equal to f cosine theta x. F of y is equal to f cosine theta y. And f of z is equal to f cosine theta z. Okay. As such, the vector of f is equal to f of x in the I plus f of y in the j plus f of z in the k. Okay? Or, if you want to make the substitutions in now, f cosine theta x I plus f cosine theta y into the j, and f cosine theta z into the k. Okay? And all the same rules apply, so angles are positive. Where'd I go here? Positive from the 0 to 180 degree axis. Okay, and theta x greater than 90 on the same side of the YZ plane. So theta of x less than 90 on the same side of the XZY plane is positive x-axis bit, and cosine theta x and f of x will all be positive. Okay. If theta x is greater than 90 degrees, then the force vector is on the other side of YZ plane. Okay, I've said that before, I think earlier in one of the videos, but in essence, you want to watch those rules, okay? Now, the vector of f is equal to f cosine theta x in the I plus cosine theta y in the j plus cosine theta z in the k. That's not a z, that's theta z. Okay, and that's that. Now, to make life a little less complicated, not have to write all that out, we're going to introduce lambda. And lambda is going to be equal to all the angles. Okay, so we can basically do this as this. Lambda x is equal to cosine theta x. Lambda y is equal to cosine theta y. And lambda z is equal to cosine theta z. Alright. The other bit of news here to just try to get your head around is theta x, theta y, and theta z are not independent. each other. Okay, and the next, so let me explain that. So each angle affects the other angle. So if I move the angle in theta x, then it's going to affect the angle in theta y, and it's going to affect the angle in the z. And so they're not independent. As one changes, the other two change correspondingly. Okay. Let's see. Next piece of this is sum of the squares are sum of the squares of the components. Okay, so we have that and that to pay attention to as we're doing these. But basically we know that. We've already done this with two-dimensional. It's not anything different here, just it is what it is. Okay, so lambda x squared plus lambda y squared plus lambda z squared will be equal to 1. As such, cosine square of theta x plus cosine squared of theta y plus cosine squared of theta z will be equal to 1. Okay. There's an equation in your textbook that will lay that out, but that's going to help us get to a lot of answers down the road that we're going to need. Okay, so just keep that in mind, and that will be that. And I think this has now gone on about 15 minutes, and I'm trying to think if there's anything last minute thing I want to throw in on this real quick. I don't think so. I think the real trick to this one is some practice problems and doing them and see where they take us. Okay, let's stop there.